Okay, this is Algebra 2, Lesson 4. This lesson talks about distributive property. What is a distributive property? Basically, it's a property of real numbers that permits us two approaches to simplifying an expression. Okay, such as this. We have 3 times 4 plus 5. We can first add the middle, right? We can use our please excuse my dear Aunt Sally, which is order of operation, which says let's do parentheses first. So 4 plus 5 is 9. Don't forget, this means multiplication. 3 times 9 is 27. Simple as that. Or, we could multiply it out. We could distribute. There are two terms. A term is separated by a plus or a minus. Therefore, you could take 3 times 4 and 3 times 5. So 3 times 4 is 12, plus 3 times 5 is 15, and I get 27. So I get the same answer regardless of whether I do it inside parentheses first and then multiply, or I multiply over the addition. This is simply the distributive property. Let's look at an example. Let's look at a complicated example. And let's look at this. It says 4a squared over b times b to the negative 2 over a to the 4th minus 3ba over a squared. Okay. Because letters stand for unspecified numbers, all the rules for the numbers also hold true for letters. So, because we said we could either add the inside first and then multiply it, or we could distribute. Well, basically, you have two terms inside this parentheses, and basically there are two fractions that are being subtracted. And it's as simple as that. And to subtract fractions, you have to have a common denominator. We haven't learned how to do that yet, so we don't want that approach. The approach we want to do is we want to use the distributive property, and we want to get rid of the parentheses. Therefore, there's two terms. This whole thing has to be multiplied by every term inside of the parentheses. So let's look at it. Well, basically, we're going to write 4a squared over b times, what's the first one? b to the negative 2 over a to the 4th. Minus, because you have a minus sign, this whole thing again, 4a squared over b times this entire term, 3ba over a squared. And there's several approaches that you can do to simplify this. So now you have two terms that you can simplify. Well, we've got a product theorem rule. We've got exponent rule, so negative exponent rule. We can do it in several different approaches. I'm going to put all my variables either all on the numerator. So in order to do that, remember we said when you do the reciprocal of a number or a variable, because it's the same thing holds true for a variable, the exponent becomes its opposite. So if it's positive exponent, this is an implied raised to the positive 1. If you do the reciprocal, that is 1 over b. The reciprocal of 1 over b is b. If you move it to its reciprocal, then the exponent becomes negative, it's positive. If it was, it becomes negative, it's positive. If it was negative, it becomes positive. So we're going to move these all to the top. So I've got 4a squared. I'm going to start with the a, so my a is next to it. This is a positive 4. This is 1 over a. Its reciprocal is a over 1, or simply a to the 4th power. Because 4 is positive, this becomes a negative. Then you've got b to the negative 2. I'm going to take this. This is b raised to the positive first power. So its reciprocal is of 1 over b is simply b. And now the sign goes from positive to negative. It changes to its opposite. Then I've got minus. This is all multiplication. Okay? I'm going to do the same thing here. 4a squared. I'm going to take this a and move it up. So a to the negative 2 times 3ba times b to the negative 1. Okay? So now that I've got that, I can come back and I can, what's my power rule for multiplying exponents? You have to have the same base. I have a's, and you simply add their exponents. You have 2 minus 4 times b, negative 2 minus 1, minus 4. How many a's? I have a squared, a to the negative 2, and this a is an implied 1. Can't forget that. So you have 2 minus 2 plus 1. Oh, and then you have times 3, and then my 2 b's. Again, that is b implied positive 1. So b to the first minus 1. So basically now I'll just combine 4a to the negative 2 times b to the negative 3. And then this is simply your integer rule. What is 2 minus 4? Negative 2. What is negative 2 minus 1? It's negative 3. Doesn't matter that it's an exponent. It's still simply only adding integers. Then you've got here 2 minus 2 is 0, plus 1 is 1. I multiply by two constants here, so I'm going to do that right now. 3 times 4 is 12. And because it's to the raised first power, it's implied, so I don't have to write that 1. b, 1 minus 1 is 0, it's b to the 0, and anything raised to the 0 power is simply 1. Therefore, this goes away, so your answer is 4a to the negative 2, b to the negative 3, minus 12a, because that b is 1, and 1 times 12a is just simply 12a. Now, can you combine them? Do you have like terms? No. You have an a and b here, and you only have an a, regardless of what the powers are. So that's as far as you can simplify it. Because they are not like terms, we cannot combine those two terms together. And that is it. Now, we learned in algebra that if you had 4 plus 3 and 4 plus 3 equals 7 is a true statement. Then we said if 4 plus 3 equals 5, that's a false statement. Alright? But we said whether it's true or false, if we add the same number to both sides, I'm going to add 5 to both sides of this equation, I'm going to get 12 equals 12. Over here, I'm going to get 12 equals 10. This is still a true statement. This is still a false statement. Regardless, if I add the same number to both sides of the equation sign, the equal sign, this doesn't change. It's still false, and this is still true. Equations that have the same solution like these two are called equivalent equations. And by this, we get our rule for addition rule for equation, which says if you add the same quantity or number, value, to both sides of the equal sign, you're not going to change your equation. Same thing holds true for multiplication and division. If you multiply every term on both sides, because you can have 3x plus 2 equals 4. You have one term over here. How many terms do you have here? You have two. A term is separated by a plus or minus. If you divide every term on both sides by the same number, or multiply it by the same number, we are not changing this equation. However, if we only do this, we've now changed the equation. So we multiply or divide every term on both sides of the equation. We don't change the equation. This is simply called the multiplication or division rule for equations. Okay? So, what are the steps for solving an algebraic equation? There's 5 simple steps, and you'll find them located on page 36, and you need to write these on your notes. I'll go over them. The first thing says eliminate parentheses. If you have parentheses on the other side, that's usually going to be your distributive property. Then you're going to add like terms on both sides. What does that mean? Well, how many terms do I have here? 2. I have 1 over here. Do I have any like terms that I can combine? No. Here? No. But if I had this, my 5 and my 2 are the same. So I can combine those and it'd be 7 plus 3x equals 4. That's what they mean by combining like terms on both sides of the equation. Then, our next step says eliminate the variable on one side or the other. If I have a plus x on this side, I have a variable on two sides of the equation. So once I've done this, it said move the variable to one side or the other. Get rid of it. Make it all on one side. So I would subtract x from both sides, and I would get 7 plus 2x equals 4. My variable is only on one side now. The next thing you would do is you would eliminate the constant term on the side with the variable. What's a constant term? It's a number without a variable. I have a constant term here and a constant term here. But it says eliminate the constant term on the side with the variable. So I don't want to eliminate this 4 because there's no variable here. I want to eliminate this 7 because this is where the side of the variable is. So I would subtract 7 from both sides, and I would simply get 2x equals negative 3. Your next step is eliminate the coefficient of the variable. What does that mean? Well, where's my variable? Right here. What's the coefficient 2? So I want to eliminate that. So I'm going to divide both sides by 2, and then simply get x equals negative 3/2. So those are the steps. Okay, do we always use them? No. And that's kind of your order of operation. That's like your please excuse your dear Aunt Sally. Those are your 5 steps for solving an algebraic equation with one term. So let's do an example here. So we're going to take 3 times 5, 6 minus 5 third x equals negative 1/2 plus x. Okay? My first rule says eliminate parentheses. Do I have parentheses? Yes, I do. I have them on both sides. Because I have them here, I have 2 terms inside this parentheses. I have 2 terms, therefore I have to use the distributive property. So basically I'm going to go 3 times 5 over 6 minus 3, keep that minus, times 5 over 3x equals, this is an implied negative 1. Negative 1 times a negative 1/2, so you have a negative times a negative is a positive 1/2. And 1 times anything is itself. Then you have a negative 1 times a positive x. It becomes a negative x. So this side is simplified. I need to finish, I'm going to simplify first, and then I'm going to have 5/2 minus 5x equals 1/2 minus x. Now your second thing says add like terms on both sides. Well, these aren't like and these aren't like, so I have nothing to combine on either side. That happens sometimes. Step 3, eliminate the variable on one side or the other. Does it matter which side I eliminate the variable? No, it doesn't. But I'm going to take the one with the biggest coefficient that is negative, and I'm going to move that over. Or you can look at it, I'm going to take the one with the smallest coefficient that is positive and move it over. Okay, because they're both negatives, that makes it simple. I'm going to take the one with the biggest coefficient. Alright, so this is a negative 5x, so to eliminate this variable from this side, I'm going to add 5x to both sides. So I simply have 5/2, because remember, anything times its opposite is 0. Negative 5 and 5 is 0, equals 1/2, and here you have the same like terms. You have a negative 1 and a positive 1. Integer rules. Different signs, find the difference, and keep the sign of the bigger number, which is 4. So this is plus 4x. So now we've eliminated the variable from one side or the other. Now we want to eliminate the constant term on the side with the variable. Where's my variable? It's on the right side. Does it have a constant term? Yes, it's 1/2. So I'm going to minus 1/2 from both sides. And simply I'm going to use my fractionals. How do you subtract fractions? Same common denominator, subtract the numerators. So I have 4/2, or simply 2 equals 4x. And this becomes 0, and this becomes 2. My last step is eliminate the coefficient of the variable. Here is my variable, there's the coefficient. So I have to divide both sides by 4, and I'm going to get x equals 2. And that is my answer. It's as simple as, oh, I'm sorry, x equals 1/2, excuse me. I do make some mistakes occasionally. So x is 1/2. You reduce. Simple as that. Let's look at another approach that might have helped us on this problem. Let's look at a simple problem like y plus 2x equals 4. If I want to solve for y, that means I want everything else on the right, so I want y by itself. So how do I get rid of this 2x? I'm going to simply subtract 2x. What would I do to one side of an equal sign? I must do the other side, or the other side of the equation. This simply becomes y equals negative 2x plus 4. What do we notice about, originally it was a positive 2x, but when we moved it over to the right, it's opposite. It's the exact same thing, but with the opposite sign. Yes? So let's look at this one. X minus 2 equals 7. I want to solve for x, so I'm going to add 2 to both sides, and x equals 7 plus 2. Right? So this was originally negative 2, but when it moved to the right side, it became a positive 2. This is simply x equals 9. But I wanted you to see that it's simply a positive 2. So basically what we're saying is every time we use the addition rule, the term will disappear on one side of the equation and reappear. It'll disappear on this side and reappear on the other side as its opposite, or with its sign change. So when you change sides, you change signs. Alrighty? This is called transposition, and it was a process that was used in algebra way back then in the 1800s by publishers. It's just a different way of thinking. So let's look at another one. So if I say p minus 3 x plus 4 equals 7y, and I want to solve for p. So I want to take this and this to the other side. So if I want to change sides, because I want to get rid of it, right, that's how I got rid of it, is I move it to the other side. I'm going to write 7y, I'm going to change signs. So this is a negative 3x becomes positive 3x. This is a positive 4 becomes a negative 4. It's as simple as that. That's all it is. It's if you change sides, like this did, you change signs. It's simply its opposite. That's all it is, and you can use this method when you're solving for equations, or you could use the long method, which says, let's get rid of all this nonsense so it's not as, okay, well first thing I'm going to do is I'm going to subtract 4 from both sides. So p minus 3x equals 7y minus 4. They're not like terms, I can't combine them. How do I get rid of that? I'm going to add its opposite, so I do it to both sides, and I get p minus 3x equals 7y plus 3x minus 4. So I get, so I get the same thing, just a different approach. Both work, either one you can use, it doesn't make any difference. That's it.